Hi, everyone. I just wanted to take the chance to go through another couple of examples of the delta math problems that involve the graphs of f or the graph of f prime. So over here off to the side, I have the things that we know from our calculus dealing with the original function and our first derivative f prime. So in this list, the very first item I have on here is that when f is positive, negative, or 0, so meaning when our function is above the x-axis, sitting on the x-axis, or below the x-axis. When we know that information, it doesn't necessarily tell us anything about f prime of x, the first derivative. So f being positive, negative, or 0, we won't be able to then interpret something about our first derivative. Whether it's where it's located, above or below the x-axis, really doesn't have an effect on what happens with f prime. But then we start to get into some of the other characteristics of f that do let us know something about f prime. So when f is increasing, we know f prime is positive. When f is decreasing, we know f prime will be negative. When f is going to have a local minimum, we know that that first derivative at that particular value is a critical value and changing from negative to positive. And the same if we're dealing with a local max, we know that f prime has a critical value, which means that it's equal to 0 or does not exist. And we also know that f is changing from a positive value down to a negative value. So what we're going to do is we're going to highlight what kind of information we have on the graph that's presented to us and see if we can then interpret what's going to happen with the other function. So I am given here the graph of f of x. And we're going to take a look first at the x is equal to negative 4. So if I just highlight where that is, x equals negative 4 is right there. So the things that we know about f of x at this point, we know that f of negative 4 is a negative value because this is sitting below the x-axis. If I could give this a set of coordinates, it would be negative 4, comma, negative 2. So we know that f of x would be a negative value of negative 2. But that doesn't tell us anything about f prime. All we know is that f of x, or sorry, let's not say f of x, f of negative 4 is something that's less than 0. Now, if we also take a look at the behavior, what kind of behavior is going on with f of x at x equals negative 4, it appears that we have a local min happening here. So we're not increasing, we're not decreasing, we're actually having a turning point that's happening with a local min. So if we know that f of x has a local min, we also know that f prime is either 0 or does not exist, and then changing from negative to positive. So we're going to know that f prime at negative 4 will be equal to 0 or does not exist. But in this case, we can kind of see that there's a horizontal tangent line, so we know it'll be 0. But we also know that f prime will be changing from negative to positive. And this is all because at x equals 4, negative 4, excuse me, is a local min. So if I'm going to jump over to the delta math option so that you can see kind of what was supposed to be selected from that table. So I know this says negative 1 and it's an entirely different graph, but I just want to show you how we would plug this in for that particular example. We had said that f of negative 4 was a negative value because it had a y coordinate of negative 2. So f of negative 4 was going to be negative. The feature was that we had a relative min that showed up on that graph. And for a sign change, we would say that there is no sign change because everything was negative. We were all below the x-axis. So we're going to say that there was no sign change. So that no sign change for that bottom row has to deal with what's going on with the very top. If this was a negative value and there was no, we're negative to the left and we were negative to the right, there would be no sign change. Now, for f prime, and again, we're working with negative 4, we know that f prime had to be 0 because we had a horizontal tangent line there. So I would say that this was a 0. It doesn't ask me about the feature. But then if we're going to have a sign change, we know that the sign changes from negative to positive. And that would be how we would fill in that table for that particular question. Now, if we take a look at the other examples in here of something else that we know, if let's take a look at the next one, which is positive 4. So we jump all the way over here at positive 4. This has got a set of coordinates that is 4, comma 0, and this is on f of x. So that means that f of 4 is equal to 0. What we also notice is going on with the graph is this graph is increasing. So we can say f is increasing at this particular moment of time. So what does that mean about f of x? So we know, or sorry, at f prime. So we would know that because f is increasing, which is what we see on the graph, we're going to know that f prime is going to be positive. Now, when they ask about a sign change, what we're going to notice is on this graph right here, which is the graph of f, right at positive 4, we do switch from some negative y coordinates to some positive y coordinates. So when you talk about a sign change, it would be negative to positive for f of x. And that's only because it's located right on the x-axis, and part of it's below and part of it's above, right in that neighborhood of x equals 4. So if I jump over to the delta math, how would I reset this? Well, the value of f of positive 4 is 0. It's not a relative min, but instead we said that it was increasing at that particular time. And the sign change, we were saying we're going from below the x-axis to above on this graph, so that would be negative to positive. And that's all for the graph of f. What we noticed about the tangent line at x equals 4 is that it is positive, and that's what we've noticed here. So f a prime of positive 4 would be positive. And then in terms of a sign change, we would not be having a sign change because this isn't a min or a max. If we're going to say that f is increasing, f prime is positive in that neighborhood. We haven't reached a max. We're not doing any turning points where we're switching from negative to positive on f prime. It's all positive in that neighborhood. So you can almost imagine, if we erase a little bit, what kind of slope would we have a little bit to the left of the 4, and what kind of slope would we have afterwards, and what kind of slope do we have at 4? They're all positive slopes. And for that reason, this final sign change here would say that there's no sign change. All of those slopes are all kind of pointing in the same direction. For our last one, we're going to consider what happens at x equals negative 1. So at x equals negative 1, we're dealing with that little corner that's right there. And again, if I were to try to assign some coordinates for this, this would be negative 1, comma 0. So that means that f of negative 1 is equal to 0. This is a local max that we have going on. So that's the feature that's going on there. And in terms of a sign change, it's underneath the x-axis and then underneath the x-axis again. So we're going to have no sign change. Now, in terms of f prime, if we start to look at the slopes, right here, this is considered to be a corner. So f prime, even though we're dealing with a local max, f prime does not exist for this type of situation because it's a corner. There's not one single tangent line that we can possibly draw, so we don't really know what the best slope is going to be. But because it's a local max, we do know that f prime would be changing from a positive slope to a negative slope because we have that local max. And we can see that we've got a positive slope before x equals negative 1 and a negative slope afterwards. So in here for delta math, kind of how we would fill this out, this happens to be sitting on the x-axis, so we're going to keep f of negative 1 at 0. The feature is that it's going to be a relative max, and the sign change is going to be the fact that there's no sign change, and that's all just by looking at the graph that was given to us. F prime of negative 1 is actually going to be non-existent, so this is what the does not exist is, and that's because we were dealing with a corner right at that location. And then in terms of a sign change, because we do have a relative maximum, it would be a positive slope to a negative slope. So those are the examples of when we are given the graph of f of x. Now we're going to switch it up and we're going to say what happens if we're given the graph of f prime. So this is looking at the first derivative. We're not looking at f, we're looking at the first derivative. So again, we're going to take a look at what happens at each one of these points, -7. So when I'm looking at this particular graph, I'm going to notice this is the point we're given here. And since this is the graph of f prime, I know that f prime at -7 is a 0. So because f prime is equal to 0, that's considered to be a critical value, and we might have the possibility where f prime is equal to 0 where we can have a change in sign. So let's see what happens with the change in sign here. This is starting at a positive value, and it's switching down to a negative value. So we're positive and we're switching to negative. So that's actually our sign change. Changing positive to negative. And this is f prime is doing that changing. So if f prime is changing from positive to negative, that leads us to the conclusion that f is going to have a local max. So f of x has a local max. That's the feature that we know is going on with f of x. So in terms of what we know so far, we know that our first derivative is a value of 0, and that the first derivative is changing from a positive to a negative, meaning it's going from above to below the x-axis. And that leads us to the conclusion that f of x will have a local max. So if I jump over to the possible options, and again, we're looking at -7, not -2 here. So if this was a different graph, I would fill out the f prime part first because that was the graph that was given to us. We said that f prime of 7 was 0. In terms of its feature, it's not a relative max or a min at each one of those. So we're going to take a look back at seeing what's happening. This is decreasing on that interval. So we're just going to say that this was decreasing. And then in terms of a sign change, if we go back to the graph, we're changing from positive to negative. So that was going to be positive to negative sign change. Now, one of the conclusions we were able to draw was that f of x was going to have a local max at -7. So we're going to select relative max. And the reason we know that it's a relative max is because f prime was changing positive to negative. Now, in terms of the value, it's actually impossible for us to know what kind of value f of x is going to have based off of this. Because if you remember back here, in order to know f of x's value, to know if f of x was positive, negative, or sitting on the x-axis, there's nothing in the first derivative that can tell us that information. We would have to know something more about f of x to be able to assume that. So we don't know. It's impossible to know what would happen there. So now we're going to take a look at another example. Another value, x equals +5. So we're jumping all the way over to here. So on this particular graph, remember, this is the graph of f prime. So this is the point that f prime of 5 is equal to a y value of 2. So we're going to have f prime of 5 is equal to 2. It's a positive value. Now, if we look at this actual graph, this is a local maximum that we have here. So f prime of 5 is a local max. And in terms of a sign change, think about, again, we're above the x-axis on the left-hand side, above the x-axis on the right-hand side, so there's no sign change. So out of all the information we have about f of x or f prime of x that's happening at 5, the only key piece of information from our calculus notes over here is that the first derivative is positive. So we know this piece of information right here. F prime is not 0, it's not changing from negative to positive or anything else. All we know is that f prime is positive, which can then lead us to the conclusion that f of x is going to be increasing. So if I jump over to the chart, how would I fill this out? F prime of 5 was a positive value. It was up there, 2. It was a relative max on that particular graph. So if you look back up here, it's at the peak of the hill, the top of the hill. And sign change, there was no sign change because you're talking about how we have positive y values and more positive y values on either side of x equals 5. In terms of our feature, what do we know about f of x's feature? All we know is that f of x would be increasing because we are working with a situation where your first derivative is positive at x equals 5. And one more time, it's impossible to know if the what kind of y value f of 5 would actually have. Last one is x equals positive 3. So if we look at x equals positive 3 right here, this is the point f prime of 3 is equal to 0. That's what we've got here. Now on this portion of the graph, this is an increasing portion of the graph. So I'm actually going to write that f prime is increasing. And if we kind of look at what kind of values we have before the 3 and after 3, we have negative values before and we have positive values after. So we're changing negative to positive. So I'm actually going to go and fill that in my table here. F prime of negative 3 would be a 0 value. It is increasing. And we know that it's changing from negative to positive. That's all by just looking at the graph of f prime. Now, out of all this information, what can we possibly say about what's going on with the graph of f? What's going on with that one? Well, the information we have is that we've got f prime is 0, so we're talking about f prime is 0 here. And we have the added benefit of knowing that we change from negative to positive, which is this part right there. So that leads us to know that f of x has got a local min at 3. So we're going to say f of 3 has local min. So I'm going to jump over here and say that the feature is that we have a relative min that's happening there. And one last time, it's impossible to know what kind of y value is sitting at that relative min because nothing about our first derivative can tell us about whether or not f is positive or negative or 0. I hope that you found this helpful. If you still want to come to office hours or you still have a couple of questions for me, please just let me know and we'll find the time to try to answer your questions.